two-phase method. So before we get into what is two-phase method, let us recall our understanding on the big M method, right? So this is the problem, a standard linear programming minimization case, in which the objective function is a minimization of z, which is equals to 50x plus 45y, and then subjected to the constraints like 2x plus 3y greater than equals to 75. Another constraint is 4x plus 3y greater than equals to 100, right? So both are greater than equals to inequality, which corroborates the minimization criterion or standard minimization criterion, right? Now this is an problem that involves artificial variable. Since the the constraints have greater than equals to symbol, so we'll be subtracting a surplus variable and add an artificial variable. So that's what basically it means, right? So first we will take equation 2. So 2x plus 3y. In order to convert this inequality into equations, we'll subtract the slack variable, which is minus 1 s1. And we also know that there is another slack variable in equation 2. So we'll subtract with 0 s2, right? Then we know we have to add an artificial variable for equation 1. That's why it is 1 t1. And also there will be an artificial variable in equation 2. So we'll put 0 t2, and this greater than equals to inequality now converts into equality, and it is equals to 75, the RHS, right? Similarly, we'll be converting the equation number 3, which is 4x plus 3y. Then we know it is greater than equals to, and also we know that from the previous the criterion, or I mean the constraint. So we have got a surplus variable, so which means that is minus 0 s1. Then for this equation, for inequality equation, we have got 1 minus 1 s2. Then we also know that it is like 0 t1 for the previous criterion, and plus plus 1 t2 equals to 100. So this is how we convert this inequalities into an equation, right? Then in order to accommodate this in simplex W, we will be adding W also. So it is just plus 0W and plus 0W, right? All right. So this will be equation 4 and equation 5, right? Then what else we're gonna do is we're gonna modify our equation 1. So z equals to 50x plus 45y. Then we will be adding the slack variable with the 0 coefficient. So plus 0 s1 plus 0 s2. And then this is a minimization case. For a minimization case, we will be in case if it involves artificial variable, we will be adding the artificial variable like this. Say for a minimization case, I'll just put ti, so I ranges from 1 to n or something like that. So plus m into ti. So if it is a maximization case, we'll be subtracting this minus m into ti. So m is a very large number, so minus m into t. So m is a very large number, so that like in a minimization case, it minimizes the objective function, right? So in a maximization case, we need to eliminate this, or we need to provide this as lesser, so that it does not affect the holistic maximization objective. So that's a basic thing that you should know at this point, right? All right. So since it's a minimization case, we will be adding the artificial variable with the coefficient m. And then what we do is we cannot directly use minimization in the simplex. So instead we will be converting that into the equivalent maximization problem, right? So W equals to minus Z. So which means that there is a factor called W, which is the minus of Z, which is minus of this equation. So every term will become minus here. And then minus Z equals to this. Then W, it is something like W equals to this, right? So W equals to minus Z, which is Z is here. So if you put everything minus, so it will become all minus, something like that. So this is W, right? So take all the factors the other way around. So like say minus 5x minus 45 minus 0 s1 minus 0 s2 minus m into t1 minus m into t2 the other way around. So when it moves other way around, it all become positive like this case, and w equals to 0. So this will become our sixth equation, which is our first equation gets converted into sixth equation, right? Now it's pretty much simple. We'll formulate the simplex W. X1, X2 is the decision variable, and these are the slack variable, and these are the artificial variable. And this is W, which is the objective function thing, and B is the right hand side coefficient. And in most of the case, this is referred as solution. So because this column will yield the solution finally, right? And this is the basis. Basis are the set of what do you call basic variable, right? So this is something like an entity that gets replaced with our decision variable, so that finally once everything gets replaced, we will get corresponding value in the solution, right? So we'll take a look at that a little later, but this is our simplex table, and these are the coefficients, like here equation, this is equation 4, 5 and 6. Equation 4 is here, and we'll put all the coefficients here for x. You can put x1, x2 or x and y, so that does not make any difference, right? So in this case, there's a typo, or you can even convert this into x and y, right? This is 2, which is the coefficient of x, and 3 is the coefficient of y, and this is called minus 1x, which is here is minus 1, and 0. Minus 0 or 0 does not makes any significance. Like when if I put minus 0, it does minus 0 plus 0 does not make any significant. Then 1 plus 1 t1, which is we are adding artificial variable to equation 2, and for t2 it is 0 the coefficient, and w is 0 here. And same way we can do it for equation 5, which is t2. I'll come back to this t1 and t2 a little later, but understand these are the coefficients like 4, 3, minus 0 and minus 1. So minus 0 plus 0 does not make any difference. So that's why I kept it plus, but you can even always retrieve it minus 0, something like that. Right, and then minus 1, which is S2, then 0 T1 and 1 T2 plus 0 W equals to right answer 100, right? So then sixth equation, which is our first equation, which is our objective function. So 50x plus 45, then all 0, 0 and m value, and another thing is m, and this W, since it is having a W, so it has a coefficient of 1, and right hand side is equals to 0, right? So this is our simplex W, and this is big M method. So we have got something called an M. So M is a very large positive number. Say generally for softwares, it will be very difficult to compute arithmetic of this thing, probably like the solving entity with and variable called M. So they define a higher number for this. Say in this case, if you can take a look at this, maximum number of this is 100. Say you can even give 500, or generally it is 1000, something like an order which is higher than the existing value. Like here 100 is there, so 45, 50, and out of this, which is bigger number is 100, so we'll give more than that, so it will be 1000. So this will become 1000 and 1000, then you can solve it by numerical. But for that will create a nuisance or something like confusion while you solve it, so we'll keep it with m itself. So if you're really interested in substituting value for m, you can very well go about and do it, but you might miss something while we take while we do computation, right? So I'll retain m as it, right? Then t1 and t2. So why we have t1 and t2 is these are the two positive terms. Like I cannot take s1 and s2 because s1 and s2 has negative values. So if it has a positive value, then I should consider that also. So that is as simple as that, right? So in this case, luckily we have only two things, T1 and T2, and this will be W, right? So this is a default. And then what initially we do is, this is pre-iteration, right? So pre-iteration, we have a quotient and elementary row operator. So add two columns. You can even do it in this itself, right? So I have uploaded a document on minimization problem in Google Drive. So take a look at that. So you don't have to make this multiple tables. This for understanding. So you can even make a long table with all the parameters in place. So this will be the header, and after that will be all the iterations and something like that, right? Right. Now we have to remove m in the t columns. Like these are the t columns, artificial variable columns. We need to remove m. Right. How do we remove this ms? When we add a minus m to it, it gets 0. Right. So how do we do it? Is we add this row, the entire row, so that this element is selected, and we'll add it with this row by multiplying minus 1 with this thing. So minus 1 into 1, and when you add that will with the plus m, that will become minus 1 into m, or minus m into 1. So that gets added with this thing, so it'll become 0, right? So that is why row 3 equals to row 3 plus minus m into row 1. That is how it, when you multiply 1 with minus m, this will become minus m. So minus m plus m will become 0. So that's what here it is, right? Then you have to do that computation for the entire row, not only for this to eliminate that, you have to do it for the entire row. Then after that, there's another m here, so we need to remove that. So you cannot use row 1 because it's a 0. So anything multiplied by 0 is just 0, so it will retain that same sound. But in order to remove this m, we'll be multiplying this particular cell with the minus m. So 1 into minus m plus m will become 0. Not only this, the entire row has to be taken. So row 3 equals to row 2, which is nothing but row 3 plus minus m into uh, row 2, right? So that's how it becomes this thing, right? So now you have removed this. Maybe I can explain you this step, like for example. So here we have got 50 minus 2m, and we know that we'll be adding that with minus m of elements in row 2, which is here it is 4, right? So it is 4. Take a look at that. 4, right? So that will become 50 minus 2m minus 4m. That will become 50 minus 6m, right? And then if you take a look at this, 45 minus 3m, and when you have got a 3 here, so 3 multiplied by minus m, that will become minus 3m. When you add both together, it will become 45 minus 3m minus 3m, that will become 45 minus 6m, right? And if you take a look at here, so here we have got 0, here we have got m. So m plus minus m into 0, which is nothing but it will retain that, so it will become m itself. Whereas in this case, if you say, take a look at that, that is 0 plus minus m multiplied by minus 1, which is nothing but minus m into minus 1 is simply m, right? So that is why we have got m here, and both will get 0. This will not be affected because in both the rows, even for the first time, when we use row 1, it is not going to be affected, and in next time it's not going to be affected also. But if you take a look at here, so in the first instance we'll be taking row 1, right? So this row 1 will add with probably initially will be 0 plus minus m multiplied by this 75, right? So that will become minus 75m, right? So once that is there, what we're gonna do is we're gonna take the third row again, and to remove m in t2, so we'll be adding minus m with the row 2, right? So that will become minus 75 plus minus m times what is there in row 2, it's 100. So 100, then that will become minus 75 plus minus 100. I just take m outside, so m, that will become minus 175m, right? So that's how we got this 175m, right? So we have removed m in the artificial variable. Now only our iteration starts, right? So I'm gonna delete this for a moment. So now the iteration starts. We take that particular stuff once it is ready. Then we need to find out a cell that has, this is the indicator cell. Among the indicator cell, we need to find out a cell that has the most negative number, right? Since we have got this in a big M method like this, so we need to find out which is the most negative number, right? So discard this B, that is not for the consideration, only this is taken for consideration, right? So I just say 45 minus 6m is the most negative number. Like, how do we sure like it is a negative number? So in the previous case we talked about, I mean in initially we talked about a value for m, right? So m to be 1000, right? So in this case I'm gonna substitute m to be 1000. So m is like it is the 550 minus 6 into 1000, which is nothing but 59 minus 5950, whereas 45 minus 6 into 1000 is 6000. Say you take a look at that. When you take a look at this, which one is most negative number? It is 5955. So this is kind of a more negative number. So that's why we choose 45 minus 6m, right? Say for clarity, I'm writing that 50 minus 6m. This is 45 minus 6m, right? So this is a very, very important thing that you should know. And we know that 45 minus 6m is higher, so we'll take this particular cell, and then we consider this particular column, and this column is known as the key column, right? So we all know this. This is just a repetition to reinforce the idea. 45 minus 6m will be the key column, and the variable corresponds to that will be called entering variable, right? So that will enter into basis here in this thing. And then what we do is we take this solution, which is b, right hand side. So what we will be doing is we will be dividing b by the key column elements. Say 75 divided by 3 is 25, and 100 divided by 3 is 33 1 by 3. So this is how we get it. You can even do this, probably you can check this if you substitute with the minus 175 multiplied by 1000 and divided by 45 minus 6000, right? So do that, it is 29.4. And among this, if you take a look at that, which one has the least positive number? 25 is the least positive among 25, 33 1 by 3 and 29.4, right? So that's why we choose this particular row. That is what we call key row. So the reason we choose this particular row is that this is the minimum value, minimum positive value, right? So for considering key row, we need to consider minimum positive value among this, right? So minimum is 25 and here is 29.4. So which is this will be the least value, right? Then the point of intersection of the key row and key column is called pivot, right? So this is the pivot. And now we will perform the Gauss-Jordan elimination process. So what does that mean is we will make this pivot element to be 1, and we will make all the elements in the key column to be 0 other than the pivot, right? So I repeat, we will make the pivot element to be 1, then all the elements in the key column other than the pivot to be 1, I mean 0. So how do we make this element to be 0 is that we divide everything excluding q and all. So till x1 to b, we divide entire row by 3, we'll get this to be 1, right? So in order to make this pivot element to be 1, so we'll divide the entire row by 3, right? So that's what it is given. Row 1 equals to, it's not equals to, it is implies, or row 1 now becomes something like that, 1 divided by 3, which is invariably row 1 divided by 3, right? So when you multiply 1 by 3 with this thing, or you divide this by 3, it's either the same, right? So now this will becomes 1, and this 2 by 3 will become 2 by 3, and I request you to leave this in the fraction itself, because sometimes decimal conversion can cause a lot of issues in your final answers, because all your answers are continuous variables. So I request you to keep the fraction itself, right, from like that. Right, so 23 and 1 minus 1 by 3 0, 1 by 3 0 0, then 75 divided by 3 will become 25, right? Now we have made one improvement here. Then what else we have to do is we have to make the other elements in the key column to be 0 other than the pivot. So these are the elements in the key column other than the pivot that we need to make it 0. So how do we make it 0 is that, so we know we have converted pivot to be 1. Say, how do we make this to be 0 is that when we add minus 3 to it. So how do we make minus 3 is that, so we will be taking row 2 plus minus 3 of row 1. So which means that here it is 1. So minus 3 into 1 is minus 3. When you add that with this thing, this will become 0, right? So in this case, let me explain that. So existing is 4, right? So we'll be adding minus 3 along with the new row, which is the row 1 or the key row, right? Something like that. So here it is. So that will become 2. I repeat, the 4 plus minus 3 stuff into this thing. Like I can even drag it like this and probably do it once again. So initially it is 3. When I add minus 3 multiply with the pivot element here, this will become 0, right? Say same way here, we know that existing itself is 0, plus we have to do it for the entire row, right? So minus 3 into here it is row 1, which is this thing, so it will become 1. So that's how 0 becomes 1 and so on, right? And finally you'll have this entire row gets done or something like that. Right. Now, what else we have to do was that we have to replicate this for this also. But in this case, we have got 45 minus 6m. How do we make 45 minus 6m to become 0 is that when we add a negative 45, so that positive 45 and negative 45 gets cancelled. And when we add positive 6m, so that minus 6m and plus 6m gets cancelled. So that this will become 0. Not only that, say for example, in this case, 50 minus 6m, and from our understanding we do that we will be taking minus 45 plus 6m and multiplied by row 1, which is nothing but here this is 2 by 3, right? So 2 divided by 3, so this is the value, right? And then this is how it is. Then we'll have, when we simplify that, it becomes 50 minus 6m, right? Then 45 minus 45 into 2 by 3 is minus 30. Then plus 6m multiplied by 2 by 3 is 2m. I think it's 2 to the 4, 4m. So that will become plus 4m, right? So when you even simplify further, it is 50 minus 30 is 20, and minus 6 plus 4 is minus 2, so minus 2m. So that is how you have got this 20 minus 2m, right? So and this gets repeated and you have got this thing, right? So the process remains the same, and we have find out the value almost in this instance like x2 is 25, but this is still an artificial variable there, so there is another iteration possible. So we will be doing other iteration, and the process remains the same. We will check in the indicator cell which has the most negative value. Say in this case 20 minus 2m, and we have 15 minus m. But we cannot take minus 15 plus 2m because plus 2m is there, so it will become always positive. Or let's take that also into consideration, minus 15 plus 2m, and we know that take m to be 1000, to be 1000. Say in this case that will become 20 minus 2000, right? And this will become 15 minus 1000, 15 minus 1000. Then probably can take minus 15 plus 2000. As I told you, it's a positive value, right? So let me put it in the right. So among this, the most negative number is 220 minus 2m, right? That is minus 1980, right? So that's how, I'll just close this for a moment, right? And that's how this will become a most negative number, and that particular column is selected. And B, so that gets selected. By mute your audio. I think it's noise. You can mute your audio. You mute your audio, please. Alright. So now we can see among this, the least is 12 1 by 2. Or you can even check this also. But minus 25 multiplied by 1000 and minus
Actually,
1.
sir,
Yeah,
so actually a lot of background noise is coming.
pardon?
A lot of background noise is coming
Yeah,
near
yeah,
me.
that's why somebody, I mean the participants only. So I just requested them to mute. I think they have muted, right? Okay, then. So we'll continue the class. Minus 2000. That will become 13 1 by 1 by 5, right? So among this, the least will be 12 1 by 2. So that particular column gets selected. That particular row gets selected. That will be our key row. Then we do the elementary row operation by making this pivot element to be 1 and rest of the elements in the key column to become 0. And once it is done, you can see that in this case x1 is the entering variable, and this t2 is the leaving variable, so which means t2 goes and x1 comes. And finally we have the value like x2, x1 and w. So x2 is 16 2 by 3 and x1 is 12 1 by 2 and w equals to minus 1375. So which means this is x2 value, x1 value, and this is the w value. And we know that w equals to minus z. So which means minus of minus this value will become z. Right. So this is how it is, right? So this is just a overview of what is big M method, right? So far we have done what is big M method, which we have done early also, but for a clarity, I'm just explaining it once more. And also it will be useful for you to understand two-phase method. Now it's extremely important stuff. It's called two-phase method. So we have got, you can see the value in the bigger method, x2 to be 16.67 and x1 to be 12.50 and z equals to 1375, right? So we can even do the same problem in a two-phase method. If you are not comfortable with m being added and this kind of an calculations are very difficult for you, you can very well use two-phase method, like so two-phase method, but it has its own limitations also. Like the method is that we'll be doing the entire simplex method into two phases. So what are the phases and how do we go about and do it, and I'll explain you. So we have got the same problem, minimize and is equals to 50x plus 45y, then subject to constraint 2x plus 3y greater than equals to 75 and 4x plus 3y greater than equals to 100, right? Now what we have to do is we'll be first creating phase 1. So in a phase 1, whatever might be the given problem, if it is a minimization problem, we'll be converting that into a maximization problem. So if a given problem is a maximization problem, then we'll be converting that into a minimization problem. So as simple as that. So basically what we do is we will be converting the z, given z, in terms of z star, right? And z star equals to maximization of minus z. So given problem is a minimization, to convert into maximization of that, so we will be taking z star equals to maximization of minus z, which is nothing but minus 50x minus 45y. So this will become our objective function, right? And also we know that in this case we have got two constraints which having greater than equals to symbol. So which means that we will get two slack variables and two artificial variables. So what we do is, since it's a maximization problem, we are subtracting the artificial variables, right? Say in this case I've told you, in a maximization problem we'll be subtracting m into t. So in a two-phase method, say in a, this is big M method. In a two-phase method, we don't have a nomenclature of m here. So instead we'll be adding 1 into t, right? So this will become 1 into t. And for a minimization case, and for a maximization case, it is a minus 1 into t, right? Say that's what the huge difference between an big M method and the two-phase method, right? So that's why we have got minus 1 into t1 minus 1 into t2. Say we have minus because it's a maximization case, right? Then you can take 50x plus 45y. Then you can even show you uh, moving entire chunk into the other way around. So everything will become, probably positive when it goes to the left hand side. So that's how it is 50x 45. And you can even see minus minus 0 s1 or minus 0 s2. Minus and plus of for 0 does not make any significance, so we'll retain it plus 0 s1 plus 0 s2. And then the minus of this t1 and t2, when you move to the right hand side, it will become plus t1 and t2. And we have got this thing. And then this will be our equation 2 uh, after converting into inequalities. Then also this will become equation 3. This is also our inequalities thing. Then this is our objective function. So kindly pay attention here. So far instead of m, we have replaced it with 1 here in objective function, right? But after that, what we do is we do a standardization of z. So standardization of z is that we will remove the coefficient of 50, x, y and all here, and we will retain it with 0, right? So in this case, the entire chunk will be 0x plus 0y plus 0s1 plus 0s2 plus 1t1 and 1t2 and 1 into z equals z star equals to 0. So that will be our objective function. So this is the one significant difference between big M method and basic simplex method, and then these two-phase method, right? So that's a basic thing in phase 1. So in phase 1 we'll be having this kind of an objective function, but the other things like in the regular fashion is the same. Like we talked about adding subtracting a slack variable and adding an artificial variable for greater than equals to symbol, and then that process remains same. Only thing is the standardization of z is the one difference thing in the two-phase method, right? Now this will become our simplex table. So it is pretty much the same. So in the earlier case we have got something called m, but in this case we have got 1. So what we do is we'll be replacing 1 here, like in the case of m in the big M method, right? So how do we remove this 1? When you add a negative 1 with the row 1, negative 1 into 1 will become negative 1 plus 1 will become 0. Same way like the one which we have done for the um, a big M method. So that's how it is, right? So we have removed that two ones in this thing by performing the elementary row operator, row operations. Let's zoom out. Okay. So that's how it becomes like row 3 is minus 1 into row 1, row 3 plus minus 1 to row 2. This will become zeros, right? So next the iteration starts. Remember, in this case, in a maximization case or minimization case, we will be taking both negative value. So this will become negative value, and this also will become a negative value. So in this case, there's a tie between maximum negative values in the indicator cell. You can arbitrarily choose any one that will automatically adjust, so that if you select this thing, we will have a key row to be this one T2. But when you select this thing, your key row will be this one, so which means that it will be automatically adjusted, right? So say in this case, I'm going to take arbitrarily this thing, first column. So since it's a maximum negative, I will take this, but first column is the key column. This is the key column, and B divided by the key column element will become Q, right? Say this will become 37 1 by 2, 25 and 29 1 by 6, right? So remember, in the previous case we have got the same thing for 29.4. That is when we incorporate value of m to be 1000, right? So in this case is fairly a numerical value, right? So once you find out among the quotient which has the minimum ratio, this minimum ratio, this is 25, positive ratio 25, and then particular row selector, that will become our key row, right? So in this case, the pivot, the intersection cell of key column and key rows pivot, and in this case is 4. In order to convert that into 1, we'll divide the entire row by 4. So that's how we divide entire row by 4. And then next step is to make this two elements, like other than the pivot element in the key column, to become 0, right? So how do we make this 2 become zeros? When we add minus 2 with the key pivot element or the key row, this will become 0. So that's how it is. We divide this entire thing by 4. That's why we make this 4 to be 1. And then we take row 1, which is equals to row 1 plus minus 2 times row 2. So that's how it is. Like here it is 1. So minus 2 times 1 will become minus 2. When you add it with this row, this will become 0. And then the same process repeats. And then in this case is minus 6. When you add 6, positive 6 with row 2, which is the key pivot element, then it will become 0, and the process repeats until it reaches here, right? So this is how it reaches here. Then we see that there is another negative term here. So we have eliminated this thing completely. Next step is to find out which has the maximum negative, right? In this case is minus 1.5. So minus 1 into 1 by 2 is minus 1.5. And in this case is just minus 0.5. Say among this, minus 1 by 2 is minus 0.5. Say among this, the maximum negative is this thing. So we'll select this particular column. That will become our key column, and this will become entering variable, and T1 will become, I'll tell you how it becomes leaving variable. So divide B by the key column elements. Like key column elements is 1 by 2, 3 by 4, minus 1, 1 by 2, and whichever yields almost here almost we get the same value. So you remember in degeneracy we talked about breaking the tie of this particular thing. So you have to perform perturbation table. So if you perform perturbation table, the first negative number occurs in this particular row. So this particular thing is selected, and that column will become our that row will become our key row, and the point of intersection of key columns and key rows is the pivot element, right? So that is taken. So here pivot is 1 1 by 2. Say we need to make this to be 1, so we have to divide the entire this thing by 1 1 by 2. So the entire row by 1 1 by 2. So we have got 16 2 by 3. And then we have to make these elements to become 0. How do we make this elements to become zeros? This is 1 now. So 1 multiplied by minus 3 by 4, when you add it with 3 by 4, this will become 0. So you proceed that step, and then you'll have this entire row ready. Then if you take a look at this as minus 1 by 1 by 2. So when you add 1 by 2 with this pivot element, this will become 0. So you do it for the entire row 3, right, plus 1 by 3 for the entire row 3 multiplied by plus 1 by 2 of row 1. Here's the row operation. Then this will become 0. Now if you take a look at that, in this case the phase 1 is terminated. The reason is that the entire artificial variable in this basis is now eliminated, right? So now it is very good to go for phase 2, right? So now phase 2, in phase 2 what we will be doing is that we will be discarding this artificial variable. We will be not needed this artificial variable anymore, right? So we will be left with this thing. We will be taking this stuff alone, right? So we'll be taking this stuff and we'll be removing this. So we'll have this thing. And a very important thing is that now the zeros of the coefficients, the z coefficients, like in the first instant we have taken 0x and 0y. Now we will be replacing with the original objective function. So this thing, right? So I can even put it like 6 star or something like that. It cannot be a 6 star because this also will be, different because this is from the iteration 2. That is how this will become 0, 0 and 1, something like that, right? So 50, 45 is the z coefficient for addition variables x1 and y. Then this is from the previous iteration. So this iteration. Only thing is we replace the 0, 0 by the original objective function 50 and 45. Right. So now we need to perform elementary row operation to make this 50 to be 0. Right. We cannot use row 1 because anything multiplied by this and you add it will become the same 50. But we can make use of this particular thing. Say if you multiply by minus 50 with this thing and when you add it with this thing, 50 minus 50 will become 0. And same way, 45, we cannot make use of this thing, but instead we can make use of this thing. So 45 plus row 1 multiplied by minus 45 will become 0. So 45 minus 45 is 0, right? Say first we'll perform this elementary row operation 50, which is row 3 minus, row 3 equals to row 3 plus minus 50 into row 2. So that's how it becomes 0 here. Say minus 50 into row 2. Whereas in this case, 45 um, plus minus 45 into row 1, which is here. So that will become 0. So that is how it is minus 45 into row, right? Now, then we have completely eliminated all the elements here. So there isn't any negative elements. So all of them are positive or 0. Right, so which means our indicator cell has no more iteration possible, so the problem is terminated. And also to be noted that we have got x1 and x2, the values for decision variable, like x2 is 16.67, which is 16 2 by 3, or x1 is 12.5, which is 12 1 by 2, and z star equals to minus 135. We know that z star equals to minus of z, or minus z equals to minus of z star. So when we take minus of minus 135, that will become 135. So this is typically the two-phase method. But this is little lengthier, but the majority of the confusions in using M might be eliminated here. But it is little lengthier when you compare to big M method for this example. But big M is little shorter, but it has got the confusing terms called M, right? So you can choose any method when there is an artificial variables in your constraint equation, right? So I think this completes the two-phase method.